you like the video, please click the like button and share the video to your friends. And don't forget to share your opinion in the comment section. And if you have not subscribed to our channel Institute of Diagnosis, please do subscribe and click the bell icon so that you will get the notifications of our new videos.
Hello everyone. Today in this video I am going to explain about flame photometer. Flame photometer is also known as flame atomic emission spectroscopy. You can see the picture of the scientists who invented this flame photometer. The person who is present on the right side is Robert Bunsen and the person who is present on the left side is Gustav Kirchhoff. These two scientists worked together and developed this machine. And this was the first model. You can see the flame in the picture here. Whenever a metal is burnt on this flame, that particular metal will emit some amount of light which will pass through this telescope and it will fall on the prism, and this prism will separate the colored light which is easily visible through the telescope which is present on the other side. So this is how our first model will work, and this is the new flame photometer which we are using in the clinical laboratories today. So let's see how it will work. So before I am going to explain you how this machine will work, I would like to share some basics of this chemistry so that you can understand what is the principle hidden behind this machine. So let's see the basics. So first of all, I would like to tell you about atoms. What are atoms? Atoms are the smallest particles of the matter or a substance or a particle or element. These smallest particles will also have the same properties like the larger particle. So let me show you one example. Here you can see the water and a water droplet. So this water droplet is not the atom. When we have made this water droplet into small particles, this looks like this. So these are nothing but two hydrogen molecules are attached with the oxygen molecule. If you see the atomic structure of a hydrogen molecule or oxygen molecule, it looks like this. There will be proton at the center and electrons of that hydrogen atom will be revolving around this proton in a circular motion, and the circular path is called as orbit or shell. So here you can see the clear structure of an atom. The protons and neutrons are always present at the center of the atom, and these together called as the nucleus, and electrons will be revolving around this nucleus in the circular motion. That circular path is called as shell or orbit. So the shell which is present inside, it is called as inner shell, and the shell which is present outside, it is called as outer shell. So whenever these atoms or element, whenever they get burnt inside the flame, they will gain some energy. That electromagnetic energy, when it hits the electron which is present inside the inner shell or ground state, that particular electron will gain some energy and it will jump to the higher orbital or the higher state. When it jumps to the higher orbital or higher state, it is unstable there, so it will release that energy and it will come back again to the inner shell or inner orbit or the lower state or ground state. You can see this one clearly in this picture. The electron moving in the second orbit has gained some energy and jumped to the fourth orbit, and there it is unstable, so it emitted energy and it is coming back to the second orbit. You can see that energy is going out in the form of a green color wave. So this is what happens to the atoms of a particle. Whenever a metal is burnt inside the flame, the atoms of that particular metal or element or a substance will take this light, and the electrons of that atom will jump from the lower orbit to higher orbit, and in the higher orbit they are unstable. So to become stable, they will again jump back to their normal state or ground state or the lower shell by releasing some energy. That released energy or that emitted energy is captured and quantified. So this is the principle of this flame photometer. When a metal is burnt in the flame, it takes some light and emits some light. That emitted light is captured and quantified. Amount of light emitted is directly proportional to the concentration of the metal burnt in the flame. So let's see the parts of flame photometer. So here you can see Bunsen burner, source of flame. Under source of flame we are having fuel and oxidizer, and lens, monochromator, detectors. Under detectors we are having photomultiplier tubes and galvanometer. So let me explain you each and every part clearly. So first let's move to the Bunsen burner. Bunsen burner, why we are using is, it will produce the continuous flame and it will mix the air and gas, and it gives the high temperature and smokeless. And source of flame. First, under source of flame we are having fuel and gas. Fuel alone is not sufficient to produce the flame. Fuel always requires the gas. So for fuel we are having three types of fuel. We can use acetylene or propane or hydrogen. And for gas we are having different types of gases to attain high temperatures. If you need 1700 degrees Celsius temperature, you can use natural gas air. If you are using propane air, you can attain up to 1800 degrees Celsius. If you are using hydrogen air, you can attain up to 2000 degrees Celsius temperature. And hydrogen oxygen, you can reach up to 2650 degrees Celsius. And if it is acetylene air, you can reach up to 2300. If it is acetylene oxygen, you can reach up to 3200 degrees Celsius. And acetylene nitrous oxide, you can reach up to 2700 degrees Celsius. And if you are using cyanogen and oxygen, you can reach up to 4800 degrees Celsius. So these are the different types of oxidant mixtures which we have to mix this air with the fuel, so that you can attain these high temperatures in the flame photometer, so that metals will get burnt in the flame photometer. So the next part is lens. Here we are having two types of lenses. One is convex and another one is the concave. So let me show you what this convex lens and concave lens will make the difference inside the flame photometer. See here, whenever the light rays falls on this convex lens, the convex lens will reflect the same light rays in the other way, and finally the light rays which are reflected from this convex lens will merge at one point. But whereas in the concave lens, when the light rays falls on this concave lens, this concave lens will reflect this light rays and they will disperse, they will move away from each other. So here we are using this convex lens in the flame photometer. So here next part is monochromator. What this monochromator will do is, first know the meaning of this monochromator. Mono means single, chromator means colored. Okay, what this monochromator will do is, whenever a light rays falls on this monochromator will separate that colored light, and it will pass only the selected colored light. So here you can see light ray is coming from the source of light, and when it falls on this dispersion device, prism, monochromator, this monochromator or the dispersion device or prism will separate that single beam of light into 7 colored lights, and a selected green color is passing through here. Okay, so this is how the monochromator works inside this flame photometer. So the next part is photo multiplier tubes. The light which is coming out from the monochromator will fall on this photo multiplier tubes. You can see in this photo multiplier tube there are different types of diodes. When light rays falls on this diode, these diodes will multiply that light. See here, one light is falling on this diode, and when it is reflected to the another diode, it is becoming double, and when it is reflected to the another diode, again it is becoming double. And this is how the light, when it enters into the photo multiplier tube, it gets multiplied, and that multiplied light is given to the galvanometer. The galvanometer will capture the light which is coming from the photo multiplier tubes, and it will measure it, and it will gives us the reading. Let's see the working mechanism of this flame photometer. The most important part of the flame photometer is a nebulizer. Nebulizer is a place where the fuel, sample and oxidizer will get mixed, and it is sprayed onto the flame. Nebulizer will be having a burner on the top and a probe on the downside. This probe will help us to give the sample to the flame photometer, and on this burner we will get the flame. Nebulizer will also have the connections like a fuel connection and oxidizer connection. From the fuel connection, the fuel will enter into the nebulizer, and from the oxidizer, the air will enter into the nebulizer. Inside this nebulizer, the oil, oxidizer and the fuel will get mixed, and we will get the flame on this burner. And the other parts are lens and monochromator and detector and galvanometer. So when we have given the sample through this probe, the sample will get mixed with this air which is coming from the oxidizer and the fuel coming from the fuel chamber, and it is sprayed onto this burner, and it will fall on that flame, and the metals which are present inside the sample will get burnt, and they will emit some amount of light, and that light is fallen on the lens. That light will fall on the lens, and lens will transfer the light to the monochromator, and that monochromator will separate the colored light, and the selected beam of light will fall on the detector, and the detector, inside the detector we are having photomultiplier tubes. That photomultiplier tubes will pass the light to the galvanometer, so that galvanometer will measure the amount of light and it will give us the reading. So let's see the sample we are giving through the probe, and the sample will get mixed with the oxidizer and the fuel, and it is made into atoms, and it is sprayed on this flame. And when they fall on the flame, the atoms, the electrons which are present inside the atoms of a substance will get excited, and they will move from the ground state to higher state, and in the higher state they are unstable, so they will emit the energy and they will come back. That emitted light will fall on this lens, and from the lens the light is transferred to the monochromator. The function of this monochromator is to separate the colored light and to pass only the selected beam of light. So the selected beam of colored light will fall on the detector. Inside the detector we are having the photomultiplier tubes. These photomultiplier tubes will pass the light to this galvanometer. So the galvanometer will measure the amount of light which is passed by this photomultiplier tubes and gives us the reading. This is the working mechanism of this flame photometer. And you can see here on the screen, whenever a potassium is burnt in the flame, you will get the violet color flame, and whenever lithium is burnt in the flame color will be changed to red color. When calcium is burnt, the color of the flame changes to orange color. When sodium is burnt, the color of the flame changes to golden yellow color. When barium is burnt, the color of the flame changes to lime green color. And what are the applications of this flame photometer? The flame photometer is used to know the presence of metal and concentration of the metals in the soil, water and food. And in the clinical laboratory, we are using this machine to identify the concentration of or to determine the concentration of the sodium, potassium and calcium inside the body fluids. So this is about flame photometer. Thank you guys for watching the video. Keep supporting.